Let's start with naming ionic compounds, which are made up of a metal and a nonmetal. The metal has a positive charge and the nonmetal has a negative charge. How do you figure out the charge? Well, you look at the periodic table. On the periodic table, you can determine the charge by looking at which column the element is in. Elements that are in the first column are going to lose one electron so that their outer valence shell is full. This means they will end up with a positive 1 charge. This continues along the column that has beryllium and boron, where they lose 2 electrons or 3 electrons for a positive 2 or a positive 3 charge. The last column in the periodic table has no charge because of the fact that their valence shell is full. The column that has fluorine is going to gain 1 electron to fill their valence shell and get a negative 1 charge. The column with oxygen will get a negative 2, and the column with nitrogen will get a negative 3. When we name and write formulas for ionic compounds, if we have a binary ionic compound, which means it is made up of 2 elements, we need to always make sure that charges are balanced. This is going to hold true for all ionic compounds. Here are 2 examples of binary ionic compounds, lithium chloride and lithium sulfide. Lithium gets a positive 1 charge on it, and chlorine gets a negative 1 charge on it. So the formula for it will just be LiCl. In lithium sulfide, lithium gets a positive charge and sulfur gets a negative 2 charge. Therefore, I'm going to need 2 lithiums in order to have enough electrons being given to the sulfur and to have a charge of 0. So the formula for lithium sulfide will be Li2S. When naming ionic compounds, the first step is to name the metal. The second step is to name the nonmetal and change the ending of the nonmetal to IDE. So the name of these compounds are lithium chloride and lithium sulfide. The only exception is if we have a transition metal or polyatomic ions. With a transition metal, we're going to need to put in parentheses after the name of the metal, and we're going to put, using Roman numerals, the charge of the metal. With a polyatomic ion, there is no name change, and we simply name the polyatomic ion. We will still need to make sure that all charges balance to 0. When we are naming and writing formulas for acids, we still need to make sure that the charges balance out. If I have an acid that is binary, which means that it only has 2 elements, the name will begin with the word hydro, and then we will change the ending on the non-metal to IC, and we'll put in the word acid. An example of this is hydrochloric acid. If we have an acid, which would be a hydrogen bonded with a polyatomic ion, then we do not do any hydro on the name. There are some rules to follow, and it depends on the name of the polyatomic ion. The rules that we follow are that if the polyatomic ion normal name ends in an IDE or an ATE, we're going to change the naming to IC, and we're not going to put any hydro on it. If the name of the polyatomic ion ends in ite, we're going to change the ending to an OUS. Again, no hydro. When we have a covalent compound, we are going to be having 2 nonmetals, so there are no charges on these because they are not going to give away or gain electrons to have a charge. Rather, they are going to be sharing their electrons. When we have a covalent compound, our 2 nonmetals have no charges to balance. We will use prefixes to tell the number of each of our nonmetals in the compound. Our prefixes are shown over here to the right. The only other rule we have is that there is not to be mono, the prefix of mono, used on the first element. So when I name these compounds, they will be named nitrogen dioxide, dinitrogen dioxide, nitrogen monoxide. Notice we do still change the ending of the second element to IDE.